Dorothy's Gatos here. Welcome to Multiplying Polynomials. Before we get into how to multiply them, let's talk about what on earth a polynomial is. A polynomial is a term, individual, or sum of term, more than one, that involves variables with whole number exponents. So let's look at these examples. First one, 4s, that is a monomial, special type of a polynomial with a variable of s. The 4s just means 4 times s. Or binomial, 5x plus 3y, that is a binomial because there's 2 terms. Now it also can have more than one variable. Or this trinomial, meaning 3 terms, x squared plus 6x plus 7. Well, here's some non-examples. 4 over s, that is not a polynomial because we are not allowed variables in the denominator. X to the 3/4, also not a polynomial because we can't have fraction exponents. They have to be whole numbers. Okay, so now that we know what they are, let's look at how we multiply them. I'm going to start with tiles just to illustrate how to multiply so that we can discover how to multiply them without tiles. So to multiply them with tiles, I put one factor along the width, the other along the length. Doesn't matter which way you do them. And then you fill in the resulting area in the middle. So let's look at an example. If I want to multiply x by x plus 1, so I'm going to take x and place it along one side and then x plus 1 along the other. Now you can call whatever color you want positive or negative, but since Miss Shu's favorite color is yellow, I'm going to say that yellow is positive. So here's x, and then along the top I'll put an x and a plus 1. Now let's fill in the area that results. So if I take x and I multiply it by x, the only thing that can fit there is an x squared. If I take an x and I multiply it by 1, the only thing that can fit there is an x. So let's write down what we've done. We've taken x and we've multiplied it by x plus 1. The result was x squared and plus x. Well, how could we do that without the tiles? Let's look. If I take x and I multiply it by x, I get x squared. If I take x and I also multiply it by 1, I get a positive 1. And that's exactly how we're going to use the distributive property to multiply without tiles. So if I have a number on the outside or a polynomial on the outside, a times m plus n, that really means a groups of m plus n, or a multiplied by m and a multiplied by n. That's what the distributive property is. So when I have a monomial, meaning one term on the outside, I distribute it in by using a rainbow. Now when we use the distributive property, we multiply exponents together by using laws of exponents. So to multiply polynomials together, I keep the base, the x, and I combine those, multiplying them by adding the a plus b. That's why x multiplied by x is x squared, because there's really a 1 here and a 1 here, and 1 plus 1 is 2. Okay, let's try that distributive property when I have a monomial of 3m on the outside. So, rainbow. I do 3m multiplied by m, which is 3m squared, plus 3m times 5, which is 15m. So that's how you do distributive property with monomials. But sometimes it's not just a monomial on the outside, it's a binomial. So let's look at how we do that. X plus 2 times x plus 1. So again, along one side, doesn't matter which, I'm going to put x plus 2. So I'll put that over here. And then along the other side, I'm going to put in an x plus 1. So there's my x tile and plus 1. Now let's fill in the area. So x and x, the only thing that can fit in there is an x squared. Along the x and the 1, all that can fit there is an x, and right underneath it, another x. Okay, along here for the 1 and the x, the only thing that fits there is just an x tile, and then 1 by 1 is a 1 and another 1. So let's look at the product here. I have x plus 2 multiplied by x plus 1. Well, let's look at what we ended up with. We ended up with x squared plus we have an x tile plus here we had 2x tiles, and then here we have 2 1s. Well, let's look at that in a little bit more detail. This is like if I had the x on the outside, applying the distributive property, x times x, I would get x squared. X times 1, I would get x. But that's when I had a monomial. But now I have a binomial, so I'm just going to do that with the 2 as well. So 2 times x and 2 times 1. So it looks like when I have a binomial, I just applied the distributive property twice. And I'm not quite done yet. To tidy this up, I just want to group my like terms in the middle. So if I have an x and I add on 2 more x's, I have 3x plus 2. That's my final answer. So let's look at how to do this without the tiles, again using the distributive property. So when I multiply polynomials, a plus b times m plus n, this means a groups of m plus n, which is here, the a groups, plus b groups of m plus n. So I distribute it in there. So I like to think of that as a double rainbow. Binomial on the outside, double rainbow. Let's try. So here I'm going to do 2x plus 3 times y minus 4. So double rainbow. Do it one at a time. 2x times y is just 2xy. 2x times negative 4, pay attention to the signs, negative 8x. And then I distribute here. Here's my double rainbow part. So plus 3 times y, and 3 times negative 4 is negative 12. Now, nothing to combine there because there are no like terms, but because I do have 2 variables, little tip for you at the bottom there, when you have terms that have 2 variables, just make sure your variables are in alphabetical order. So x and y is in alphabetical order already, so that would be my final answer. So what happens if there's more than one operation? Well, anytime there's more than one operation, we need to refer to BEDMAS. We need to follow the order of operations. So notice how I wrote BEDMAS, maybe a little different than what you've seen. Here's why. B is the very first thing, I do brackets. So if there's something to be done inside the brackets, I do that first. E stands for exponent, so I do exponents second. And then divide and multiply in the order they appear from left to right. So I don't want you guys to think that it has to be divide and then multiply. That's why I write them on the same level. It's just whichever one comes first. Same thing for adding and subtracting, again from left to right. So let's try an example. This one here, I have 2x minus 3 squared minus x plus 1 times 5x minus 4. So first of all, let's talk about what squaring a number means. It means multiplying it by itself. So I'm going to write it out twice. Minus x plus 1 times 5x minus 4. So now I've done my exponents. Now I'm going to follow order of operation and I'm going to multiply from left to right. So I have 2 products that I'm subtracting. So because this is a binomial, I'm doing double rainbow. So 2x times 2x, 2x times negative 3, negative 3 times 2x, and negative 3 times negative 3 is positive 9. That is my first product. Subtract, let's look at my second product. X times 5x is 5x squared. X times negative 4, negative 4x. 1 times 5x, and 1 times negative 4. I like to do my rainbow as I go. So as you draw one, write down the product. Okay, so let's tidy this up a little bit. Grouping my like terms. If I have negative 6x and I add another negative 6, I altogether have negative 12x. Over here, 5x squared. If I have a negative 4x and a 5x, I have x and then minus 4. So now I'm going to subtract, and I'm subtracting term by term. So I have 4x squared and I take away 5x squared. That's negative x squared. I have negative 12x and I take away an x is negative 13x. And then lastly, I have a 9 and I take away a negative 4. So take away a negative 4, 2 negatives make a positive, becomes 13. And that would be my final answer. So that's how you do questions involving order of operations. I have a really important question for you, though, to end this lesson, and that is, what do you call a parrot who won't eat? Well, very fitting to today's lesson, you call it a polynomial. Polynomial, he's not eating, polynomial. That's pretty epic. So I hope this video helped, and I look forward to seeing you for the next one.